Variable is just a place in memory that an object can be stored in. The variable should have an identifier, which is just a name given to that piece of memory so that you can, in the future, retrieve that object from that location in memory and manipulate it and do whatever you want with it. But the identifier, there's a few rules for identifiers. It's the first character of an identifier should be a letter or an underscore. The rest of the identifiers can be letters, numbers, or underscores. There can be no spaces. Usually you use the underscore if you want to put a space in. Identifiers are case sensitive, and in the example you'll see that these two identifiers are not the same, my name and my name. My name here has a capital in the name. The N is capitalized, which makes it different than the lowercase n. Valid identifier is I, which is a common identifier. Var is a common identifier. X is a common identifier. And the main thing is just no spaces. You can't start your identifier with a number. And yeah, let's get into using some variables. So this first one here is, I've got three identifiers, and X, Y, and Z are all identifiers, and they're separate locations in memory, and I'm storing 0 in all three of them, which we'll see if I increment x plus 1 would increment 1, so x would be 1. Similarly, but with less keystrokes, I can say x plus equals 1, and it should increment to 2 now. So you can also use the same concept with multiplication, division, and other math functions. So x times equals 2. We would expect that to be 2 times 2 equals 4. And maybe try this one as well, x 2, and then x equals 2. So you'll notice that if I was to switch the order of these two, we'd get either an error or syntax error. So the order that these two are placed is important. And just for so now x is going to equal 1. So it changes everything. It's very different. It does a different thing. Yeah, let's go to the next slide. So let's see, if I store x is equal to 0.5, it will overwrite what we had previously of 1. So it's the same identifier, same place and location, but when I reassign the value 0.5 to x, x is going to equal 0.5. you can do some math on these variables. So let's say x times 3, 1.5, what you would expect, x to the power 2. Yeah, so let's continue. Right now, y is equal to 0 because we set it equal to 0 up here, and now we'll go y equals 111, and then y plus 222, and we would expect that. So in this situation, you'll notice that it does not change y. So y is still going to be 111, but you're basically saying 111 plus 222. It's just it's y is saying the exact same thing as 111. So let's try this. How about y? Again, we can override the previous 111 storage in y, and so what would we expect to get here? 1, most likely. Oh, but nothing. Oh, because I didn't import math. Yeah, okay, import. That's a good reminder that we need to import math, and I'll just one, like we thought. So that's an important reminder that we've got to import math anytime we want to use a math function. I just forgot to do that, but it'll remind you pretty quick. So that's variables. Next, we'll talk about data types. Variables are pretty basic concept, and I think you've already learned them in the MATLAB videos. So next we'll move on to data types, and data types are a little different in Python than MATLAB. So yeah, we'll see you in the next video.